Hello, I'm Glenn Darling from the Open Horizon team, and I'd like to give you an introduction to Open Horizon. Imagine a world where even the simplest electrical devices have a powerful CPU and a network connection. That's not really very far away today, and the outer edges of the network are ever growing in number and capabilities. And if you take a look at the picture on the right hand side, it's one of my favorite little devices. These came out in 2014, the ESP8266. It's a 32-bit CPU with RAM and flash storage and onboard Wi-Fi. And this little piece of hardware sells for $1 retail. So in mass quantities for production use, they're very, very cheap. And they have an extremely low power mode, which enables them to run on that pair of AA batteries for over a year. So the telco edge, the business edge, and even the home edge are all seeing big changes right now, and there are also some very interesting big changes on the near horizon, like 5G. And within a single realm, like a factory, an office building, or a residence, we can expect thousands of heterogeneous devices that are going to require some kind of application software lifecycle management. And this is where Open Horizon comes in. Open Horizon uses autonomous agents on Linux that control Docker to secure and manage containerized workloads on small devices. Typically, these devices are behind firewalls, and you want to manage them with zero touch because there are so many of them. There'll be thousands of them. It's difficult for you to go to each individual device. The agents are fully autonomous and governed only by the deployment pattern you install upon them or the policies that you specify when you configure them. And the scales that Open Horizon can handle today are in 10,000 range. We currently test with 10,000 devices, and we're working to bring that number up to 1 million very soon. The hardware that you require to run one of these autonomous agents is either x86-64 or ARM32 as low as v6 and above, so HF, v7 all are supported, and ARM64. And the processor can be really weak, only needs a single core, and we regularly test on 512 megabytes of RAM with 32 gigabytes of storage. And in practice, the agent itself typically runs about 28 to 30 megabytes of RAM usage. So it's very small, but of course you need the operating system and Docker, and you need whatever application software you're deploying using the agent. So you need a little bit more than the minimum for the agent, but a very small footprint is required. Also, if you take a look at the diagram on the right, the part of the diagram at the top, I show the agents connecting to the management hub, and then at the bottom I show little tiny devices connecting to the agent and the agent connecting to the management hub. So it's possible to have your device that has Linux and Docker and runs the agent act as a gateway for smaller devices that don't. So for example, that ESP8266 device that I showed at the start of the presentation, it is not able to run Linux or Docker, so it could use one of these devices that is running Linux and Docker as a gateway to get it connected. So now let's take a look at some of the components that are in Open Horizon. So first of all, you need some edge devices. There's an Atomic Pi based on the Intel Atom. There's a Raspberry Pi Zero W, which is an ARM32 v6 with a single core processor and 512 megabytes of RAM. And there's an NVIDIA Nano, which has a NVIDIA Maxwell GPU. It's really great for inferencing on the edge. And ARM processors in the Raspberry Pi, Model 3 and 4. And there's also NVIDIA Jetson TX2, which is a great inferencing device for the edge. But as I mentioned before, these can be very small. Single core, half gigabyte of RAM in any one of those architectures. But in the core, in the management hub, you need to have something a little bit more substantial. And so this is typically, the components in our management hub are typically deployed in a Kubernetes cluster. And that requires server class machines. Now, the management hub contains a number of software components: the sync service, the switchboard, and the exchange, and then possibly a few agbots or agreement robots. And then over on the edge device side, there is an agent that must run on every one of the edge devices. And the agents are designed to function behind a firewall because that's the most common deployment. But the agbots are actually also designed to be able to run behind a firewall. So if you wish, you can deploy agbots on edge devices as well, but that's less common. So they're usually deployed just as part of the management hub. Now, the agents on the devices, they always reach out to the various components in the management hub. So the agent you don't need to open any ports in the firewall. The agent just needs to be able to access the management hub. The management hub can be in a public cloud environment, or it could be in a private cloud environment, or a company data center, or in a telco edge facility, or on a factory floor. Even you could have your management hub. It's useful in an environment where you need to be cut off from the internet. So you don't. This can work in an environment where you are completely air-gapped from the internet, as long as the agents on your edge devices can reach a management hub somewhere. Now, once the agent has gotten information from the management hub about what software to run, it just needs to reach out to the Docker registry and get that software. And the management hub is not involved in that at all. Once the agent has its information, it goes off and autonomously works. So this actually reduces the load on the management hub, because these agents act autonomously by themselves, and they can pull the information from whatever Docker registry. It can be a public registry or a private registry with credentials. Either one works. Then once the agent has downloaded and validated, check the cryptographic signatures, hashes, appropriate configuration to make sure it matches the patterns or policies on the agent, then it will go ahead and run that code in a sandbox. And that code, it can do anything you like. Open Horizon pretty much stays out of the business of the data plane, as we call it. The role of Open Horizon is to be the control plane to set up the software and get it running in the right places and make sure that it's the correct software to be running there. But the software itself can do any kind of communication, send data to the cloud, or send data to some other part of the factory, or receive commands from some other part of the factory or the cloud or whatever. Now let's talk a little bit about differentiation, what makes Open Horizon different from other solutions we have seen. Devices are configured with the fully autonomous agent, and it manages the container software lifecycles on the device. The management hub enables communication and data sharing for the devices because they're behind firewalls. So the management hub needs to be well known to the agents, and so when you configure the agent, you configure it to point to a particular management hub. The management hub components are there to enable the agents to negotiate and collaborate on the software management on their devices. And devices can continue to function even with poor or intermittent network connectivity, for example, when they're unable to contact the management hub. The decentralized architecture of this system facilitates massive scale because the agents can go ahead and act autonomously. The management hub components are designed for massive scale. They're typically provisioned with multiple instances of each of the services. They're load balanced, and they can be globally distributed. They're designed to protect the privacy of the other components, especially the edge devices. And they're designed with constrained scopes of authority, so each one has authority for only its own domain. And there's a separate presentation regarding the security of Open Horizon that goes into these details in much more concrete detail. But suffice to say, if any edge device is compromised, the risks to other edge devices are minimized by this approach. So the central components have very little authority. The exchange enables agbots to find agents, but it has no authority over the agents or agbots. Agents and agbots act autonomously. The switchboard is just a dumb and blind mailbox service, and it's incapable of eavesdropping, altering, or inserting any agent-agbot messages. The agent and agbot each create a mailbox that has an address that is their public key. And when one of the others wishes to communicate with it, it encrypts the message and puts it in their public key mailbox. Only the agent receiving the message can decrypt the message. So they decrypt the message and can read it and can respond in like kind back to the other side. But the switchboard in the middle has neither private key, so it's not capable of decrypting. It's not capable of creating new messages. So it's really just dumb and blind. And the sync service is just a data file syncing service, enabling data to be passed around. The agents are the most numerous components, and together with the Agbots, they do most of the work in the system. The agents have no authority outside of their device, so the only credentials that the agents have enable them to work on their own device and nowhere else. They have no authority anywhere else in the system. They're completely autonomous, so the device can be managed with zero touch once the agent is configured. They're driven by policy or by a deployment pattern, and a deployment pattern is simply a simplification layer on top of the policy mechanism. Agbots know nothing about the agents that they're communicating with except their public key and their mutual interest in a particular deployment pattern or a particular set of policies. The Agbots don't even know the IP addresses of the agents that they're communicating with. They just know their public key, and that's how they address them. The Agbots provide information to the agents, but again, the agents make their own decisions and do their own validations of the published services and the Docker containers within them and the configurations for those Docker containers. That's the end of this brief introduction. I hope you have a better understanding of Open Horizon. If you have additional questions, please check out the other videos, and you can contact me at glendarling@us.ibm.com.